Let n be 2 to the power of 2, 3 to the power of 3, 7 to the power of 7. How many factors of n square are less than n but not factors of n? Now it is given that n is equal to 2 squared multiplied by 3 cubed multiplied by 7 to the power of 4. Note that 2, 3 and 7 are all prime numbers. Therefore, all factors of n will have to be multiples of 2, 3 and 7 only. For example, if another number m is equal to 6 to the power of 3 multiplied by 15 to the power of 5 multiplied by 21 to the power of 2, then the factors of m will not only be the multiples of 6, 15 and 21, but also multiples of 2, 3, 5 and 7 also, because 6, 5 and 21 are not prime numbers and they themselves have other factors like 2, 3, 5 and 7. Coming back to n, its factor will therefore be all the numbers given by 2 to the power of p, 3 to the power of q, multiplied by 7 to the power of r, where p is between 0 and 2, q is between 0 and 3, and r is between 0 and 4. Both 0 and 4 are included. That is, p can take one of three values, 0, 1 or 2. Q can take one of four values, 0, 1, 2 or 3, and R can take one of five values from 0 to 4. Each of these values of P, Q and R will result in one factor of n. For example, when P is equal to 0, Q is equal to 2 and R is equal to 1, we get a factor 2 to the power of 0 multiplied by 3 to the power of 2 multiplied by 7 to the power of 1, that is 1 multiplied by 9 multiplied by 7, that is 63. So 63 will be a factor of n. Similarly, when p is equal to 2, q is equal to 1 and r is equal to 3, we get another factor 2 to the power of 2, 3 to the power of 1 and multiplied by 7 to the power of 3. That is 4 multiplied by 3 multiplied by 343, that is 4116. Since p can take 3 values, q can take 4 values and r can take 5 values, the total number of factors of n will be 3 multiplied by 4 multiplied by 5, that is equal to 60 factors. Of these, n itself will be a factor. So there will be 59 factors of n that will be less than n. Since n is equal to 2 to the power of 2 multiplied by 3 to the power of 3 multiplied by 7 to the power of 4, we get n square is equal to 2 to the power of 4 multiplied by 3 to the power of 6 multiplied by 7 to the power of 8. So any factor of n square will be of the type 2 to the power of a multiplied by 3 to the power of b multiplied by 7 to the power of c, where a is between 0 and 4, b between 0 and 6, and c is between 0 and 8. Both 0 and 8 are included. Thus, A, B, C each can take one of 5, 7, and 9 values respectively. Therefore, the total number of factors of n square is 5 multiplied by 7 multiplied by 9, that is equal to 315. Before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds. And you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Now try to understand the following statement. For each factor of n square less than n, there will be a corresponding factor of n square greater than n such that product of the two factors will be n square. As an example, let m be 12, then m square is 144. Factors of m less than m are 1, 2, 3, 4, and 6. The corresponding factors of n square greater than m are 144, 72, 48, 36, and 24. Note that 1 multiplied by 144 is 144, 2 multiplied by 72 is 144, 6 multiplied by 24 is also 144. In general terms, if u is a factor of n, u is also a factor of n square. If n squared by u is equal to v, then u multiplied by v is equal to n square. Therefore, if u is less than n, then v has to be greater than n. Now, n has 315 factors as we have seen above. Out of this, 157 factors will be less than n. Call these factors as category A factors, and 157 will be greater than n. Call these the category B factors, and one factor is number n itself, so that 157 plus 157 plus 1 is equal to 315. Since every factor of n is also a factor of n square, it follows that all the 59 factors of n, as you have seen n as 59 factors excluding n, so it follows that all the 59 factors of n will be present among the 157 category A factors. Therefore, amongst the category A factors, there will be 157 minus 59, that is 98 factors that are less than n but not factors of n. All category A factors are factors of n square. Therefore, there are 98 factors of n square that are less than n but not factors of n. That is the answer. Thank you.